Okay, so you crushed it. You got through Units 1 and 2 advanced programming.
Yeah.
You know, your variables, your functions, your loops, all that good stuff. But buckle up, because Unit 3,
Yeah.
things are about to get really, really interesting.
It's true. Units 1 and 2, those were really just laying the groundwork. Now we're getting into the fun stuff. We're talking interactive applications.
Interactive applications. Yeah, okay, now you're speaking my language. What's that mean exactly?
Well, think about it this way. Up until now, your programs have basically just been following instructions, right? You write code, the computer does what you tell it to do, pretty straightforward. But with interactive applications, the program actually responds to the user in real time.
Yeah, well, hold on. Responds in real time. How does that work?
That's where things get interesting. It all comes down to something called event handling. Basically, you're setting up your program to listen for specific events, like a mouse click, a key press, even just moving the mouse across the screen. And then when that event happens,
Yeah.
bam, specific chunk of code is executed.
So it's like setting a trap. If this, then that.
Exactly. And to manage all of these events and triggers effectively, we're going to introduce you to a powerful concept called the Model View Controller Pattern, or MVC for short.
MVC.
Okay.
I feel like I've heard that before, but I need a little refresher. What is that all about again?
Sure. So imagine you're building a house.
Okay.
The model, that's like the foundation, the framework, it's all the data and the logic that makes your program work behind the scenes. The view, that's like the walls, the roof, what everyone sees. It's how you present that data to the user, usually through a graphical interface. And the controller, well, that's like the electrician, the plumber, making sure everything is connected and working together. It manages the flow of information between the model and the view.
Okay. I think I'm starting to see how this all fits together. So if we're building a simple game, for example,
Yeah.
the game's logic and data, that would be the model. The visual stuff, that would be the view.
Right.
And the controller would handle all the user interactions, like you press a key to move a character or something like that.
You got it. See, it's all about keeping things organized. Especially as your programs get more complex, MVC helps you separate the different parts of your code so it's easier to understand, easier to maintain, and much less likely to turn into a tangled mess.
Okay, that makes sense. Keeping things organized is key, especially when you're talking about something as complicated as interactive applications. But you mentioned building games. What kind of games are we talking about here? Are we going to be making the next Fortnite or something?
Whoa, now, let's not get ahead of ourselves. We're not going to be building anything quite that complex in this unit.
Okay.
But we are going to introduce you to the core concepts of game development. And trust me, once you learn how to build a simple game from scratch, you'll start to see the possibilities are endless.
Okay, so what kind of games will we be making?
Think more along the lines of classics, Pong Snake, maybe even a little Tetris down the line.
Tetris, you say. Now, that's a game I can get behind.
Right.
But before we get lost in a world of falling blocks, let's bring it back to the here and now. What are some of the essential programming techniques we'll be learning in this unit?
One of the big ones is object-oriented programming. Remember how we've been working with individual variables and functions? Well, object-oriented programming takes those elements and groups them together into more complex structures called objects.
Objects? Like real-world objects?
Kind of. Think of it this way. Let's say you're creating a program to simulate a car.
Okay.
In object-oriented programming, you wouldn't just have separate variables for the car's speed, its color, its fuel level. Instead, you'd create a car object that encapsulates all of those attributes and more.
So it's like bundling all the relevant information and actions together into one neat little package.
Exactly. And just like a real car, this car object would have various methods or functions associated with it. Things like accelerate, brake, change gear, you name it.
Okay. I think I'm starting to get the hang of this. So instead of thinking about individual pieces of data, we're now thinking about these self-contained objects that interact with each other. It sounds like a completely different way of approaching programming.
It is a different way of thinking, but once you grasp the fundamentals, you'll find that it's incredibly powerful and intuitive.
Wow.
And trust me, when you start building more complex applications, object-oriented programming will become your best friend.
Well, you've convinced me. Object-oriented programming it is. But before we dive headfirst into the world of objects, I have to ask. What about those timer events you mentioned earlier? I have a feeling those are going to be crucial for creating interactive games.
You're absolutely right. Timer events are essential for introducing the concept of time into your programs. They allow you to schedule events to happen at specific intervals or after a certain delay.
Okay, so it's like setting an alarm clock for your code.
Exactly. Let's say you're creating a game where an enemy appears every 10 seconds. A timer event lets you execute that spawn enemy code right on schedule.
This is blowing my mind. So we're not just telling the computer what to do, but when to do it as well.
Precisely. And that level of control is what allows you to create truly dynamic and engaging applications.
Okay, I'm officially hooked. This is way more exciting than just printing "Hello World" on the screen. Yeah. I can't wait to see how all of these pieces come together to create those interactive games we talked about.
It is. And that's what makes Unit 3 so exciting. You get to take all of these powerful concepts and actually turn them into something people can interact with.
You know what? I'm all about that, but I'm not going to lie.
Yeah.
This is a lot to process.
Right.
Object-oriented programming event, handling timer events, MVC. It's a lot. Where do we even begin?
Well, the good news is we're going to take it step by step,
Okay.
just like we did with Units 1 and 2. Remember, you started with the basics, variables, data types. Then you moved on to functions and loops, building upon each concept gradually. Unit 3 is no different. We're going to break down these complex ideas into smaller, more manageable chunks.
Okay, so we're talking about taking a divide-and-conquer approach.
Exactly. And one of the best ways to learn these concepts is to apply them to simple examples. Remember those classic games we talked about, Pong Snake? Those are great starting points because they demonstrate the core principles without being overly complicated.
Okay, I like where you're going with this. Let's say we're building a simple game of Kong. How would we use something like object-oriented programming to structure that?
Okay, so in Pong, you've got 2 paddles and a ball, right? Each of those elements can be represented as an object in our code. You'd have a paddle object.
Okay.
And that object would have attributes like its position on the screen, its size, its speed.
And probably a method for moving up and down, right?
Exactly. You'd have methods for moving the paddle up, moving it down, and probably even a method to detect when it collides with the ball.
Okay, so we're defining all the characteristics and actions of the paddle within that object.
Precisely. And then you'd do the same thing for the ball, a ball object with its own set of attributes and methods.
So its position, its speed, its direction of movement.
Right. And methods for things like bouncing off the walls or the paddles even detecting when it goes out of bounds.
Okay, this is starting to make sense. So by creating these paddle and ball objects, we're essentially encapsulating all the data and logic associated with those elements in a way that's organized and manageable.
Exactly. And here's where things get really cool. Remember event handling? Well, we can use event handling to make those paddles move in response to the user's input.
Oh, I see. So like if the user presses the up arrow key, we can have an event handler that triggers the move up method of the left paddle.
You got it. And we could do the same thing for the down arrow key and the right paddle.
Yeah.
Suddenly our Pong game is starting to come to life.
This is incredible. I'm starting to see how all of these pieces fit together. We've got objects interacting with each other, event handlers responding to user input. It's like this intricate dance of code.
It really is. And we haven't even talked about timer events yet.
Oh, right. Timer events. Almost forgot about those. How do they fit into our Pong game?
Well, we could use a timer event to control the speed of the ball. For example, we could set a timer to increment the ball's position every few milliseconds, creating that illusion of movement.
So the timer event is what introduces that element of time into the game.
Yeah.
Making things happen at specific intervals.
Exactly. And when you combine timer events with object movement, you can create animations, you can control the pace of the game, build all sorts of interesting time-based mechanics.
This is blowing my mind. I never realized how much goes into creating even a simple game like Pong.
It's all about understanding those foundational concepts. Once you have the building blocks, you can start assembling them in countless ways to create more complex and engaging applications.
Okay, I'm totally on board with that. But let's zoom back out to the MVC pattern for a second. How does this model view controller thing apply to our Pong game? I need to make sure I'm connecting all the dots here.
That's a great question. So remember, the MVC pattern is all about organizing our code effectively. So in our Pong game, the model would encompass all the data and logic that makes the game work.
So things like the position of the paddles and the ball, the score, the rules of the game.
Exactly. The model is all about the what of the game, what's happening behind the scenes.
Okay, that makes sense. And what about the view?
The view is all about the how. How is all of that data and logic presented to the user? So in Pong, the view would handle everything the user sees on the screen.
The visual representation of the paddles, the ball, the score, the background, basically the game's graphical interface.
You got it. The view takes care of all the visual stuff. And then we have the controller, which is like the intermediary between the model and the view.
So the controller would handle things like user input, like pressing the arrow keys to move the paddles.
Right, and then it would update the model accordingly.
And once the model is updated, the controller would tell the view to update what the user sees on the screen.
Precisely. For example, if the user presses the up arrow key, the controller would tell the model, hey, move the left paddle up. And then the controller would tell the view, hey, redraw the left paddle in its new position.
Okay, that's a really helpful way to visualize it.
Right.
It's like
Yeah.
this constant communication loop between what's happening in the game's logic and what the user is seeing and interacting with on the screen.
Exactly. And the beauty of this MVC pattern is that it's not just for games. It's a powerful concept you can use in all sorts of programming projects.
So like a Swiss Army knife for programmers.
Exactly. Once you understand MVC, you can apply it to all kinds of applications.
Okay, you've sold me MVC is the way to go. But let's get practical for a second. We've talked about all these concepts: object-oriented programming event, handling timer events, MVC. But how do we actually start putting this stuff into practice? I mean, I don't want to get ahead of myself and try to build the next big thing right out of the gate.
And you don't have to. The key is to start small and gradually work your way up to more complex projects. Remember how you learned to ride a bike? You didn't just hop on and start doing backflips.
Well, yeah.
You started with the basics, finding your balance, figuring out how the pedals work. Programming is the same way.
Okay, so what you're saying, we need to find our coding training wheels?
Exactly. Start with something simple. Something that lets you practice these concepts without getting overwhelmed.
So like those classic games we were talking about.
Exactly, Pong Snake. Those are great starting points because they're relatively straightforward to build, but they still incorporate many of the core concepts we've been discussing.
Okay, so let's say we're working in that Pong game. What's a good strategy for tackling that?
Well, one helpful tip is to break down the problem into smaller, more manageable sub-problems. Instead of trying to build the entire game at once, focus on one piece at a time.
Okay, so like divide and conquer.
Exactly. For example, start by just getting one paddle to move up and down on the screen.
Yeah.
Once you have that figured out, then focus on getting the ball moving. Then work on collision detection.
So it's kind of like building a puzzle, one piece at a time.
Exactly. And as you complete each piece, you start to see the bigger picture emerge.
Yeah.
And don't be afraid to experiment. Make mistakes. That's how you learn.
Yeah, those happy accidents can sometimes lead to the best breakthroughs.
Absolutely. So embrace the challenge. Don't be afraid to get your hands dirty with the code. And most importantly, have fun with it.
I love it. Embrace the challenge and have fun. That's some sound advice right there. So as we wrap up this deep dive into Unit 3, what's the one thing you want our listeners to take away from this?
I want them to remember that Unit 3 is about more than just learning new programming concepts. It's about unlocking a whole new world of creative possibilities. With these tools and techniques, you can bring your ideas to life in ways you never thought possible.
That's awesome. So as our listeners gear up for Unit 3, any final words of wisdom?
Just one dive in, get your hands dirty, experiment. Don't be afraid to make mistakes. That's how we all learn and grow as programmers.
That's great advice. Well, folks, there you have it, an inside look at what awaits you in Unit 3. Get ready to level up your coding skills, unleash your creativity, and build some amazing things. Until next time, happy coding.